So hey guys, welcome back to my channel. Hope you are doing extremely well, and this is your very own mass code at this side. So today's question is number of occurrences. What does the problem state? The problem state that you have an array, right? You have an array, right? And you have a target value, right? Target value. Now the problem says that this array is actually sorted. As you can see, the example I have taken 1, 1, 1, 2, 2, 2, 3, 3. All the elements are sorted. And you have been given a target value. Now you have to find the number of times this target value occurs in this particular array. Target value here is 2. If you see, this is a 2, this is a 2, this is a 2. So this is 1 2, second 2 and a third 2. That means my answer for this question should be 3. That is, this target value, that is 2, is occurring 3 times, right? Okay. Coming to the approaches, how will you solve it? So the brute force approach is actually very clear to you. What will you do? You will traverse. You will traverse the array. You will say this is not 1, this is not 2, this is not 2, this is 2. So you will take an answer equals to 0, and as soon as you find a target value, you will increment it. This converts to 1. This here again 2, increment to 2. This here again 2, increment it to 3. This here not 3, this here not 2, this here not 2, and the array finishes. The final answer stays with you as 3 and you can return it. Okay. What is the time complexity to do so? Because you are traversing it one times, you are using O of n time complexity, and because you are not using any extra space, it is O of 1 space complexity. This is time and this is space. This is the brute force, right? So brute force is also very optimized, but can we optimize it more? Let me look. Let me look. Okay, so my array looks like 1 1 1 2 2 2 3 3. Okay. Things I have noticed about is sorted. This particular keyword is actually forcing me to think something, right? This particular keyword is actually forcing me to think something, because the brute force approach which we applied above can be applied on unsorted as well, right? So sorted is also playing a role here. What is the role? Let us determine that. Now, because it is sorted, whenever the array is sorted, you should obviously think about binary search. Sorted array should give you an indication of using binary search, and that is very evident for any DSA problem. Sorted should actually link binary search. Now, how can I use binary search here? I don't have to find only one value, right? If I don't have to find only target value are 3 times here, right? So what do we do? Can I use the concept of finding first position of target value, finding first position and the last position of target value, right? So what is the first position? This is this. Last position, this is this. What are the indexes? This is 0 1 2 3 4 5 6 7. That is, first position is occurring at third index, last position is occurring at 5 index. So that means 5 minus 3 plus 1 will actually give me 3. So if I find the first position, if I find the last position, my answer is given to me. My answer is given to me. Now how should I do that? How should I do that? So finding first position, last position, actually very simple. What do we do? What do we do? For finding first, let me write it down. For finding first, 1 1 1 2 2 2 3 3. What will you do? You will keep your low here, you will keep your high here. Indexes are 0 1 2 3 4 5 6 7, right? And you will say my first is stored as -1. Why -1? Because I have not found my target up till now. Okay, your mid will be 0 plus 7 by 2. Mid equals to 0 plus 7 by 2, which is equal to 7 by 2, which is equal to integer division 3. Your mid comes here. You will see your mid is equals to target. Your mid is equals to target. So assign this value to first. First changes to 3, index 3, right? Now because you need to find first, that means first occurrence will occur at left part. See, you found the first part here, you found 2 here, so you will say my first occurrence will come on the left part of it. That is, I will shift my high to here, right? High will be equals to mid -1 for target value, right? But suppose your mid would have landed here. Let me reverse the steps, right? Suppose Suppose your mid would have landed here, for example, right? So what will you do now? What will you do, right? For this case, you can see that, like, because your mid is lying on the like the element on the mid is one, you require two. That is, because it is a sorted array, you will have to scroll the right part of it. For this case, you will have to say low equals to mid plus one. For target is greater, right? And suppose you landed at 3, your mid landed at 3, that is the third case. Your mid landed here. Now you will say target is greater, so you will again say high equal to mid minus 1. So high equals to mid minus 1 to left, check the left part. For target is smaller, right? This will go up till your low is actually less than high, right? Your low is actually less than high. Okay, less than equals to high, you can also say, right? Similarly, for last, these conditions will change. While finding the last position, only this condition will change. Here, your low will change to mid plus 1. Why? Because for finding last position, suppose your mid lands here, right? You found your mid. Now you say that I have to explore the right part also to find the last position. So you will say, because this position can contain my last element, which is here, I will say low equals to mid plus 1. That is, low will come here and then you will proceed, right? Then you will proceed. So let me work out a dry run. What I'm trying to say is 1, 1, 1, 2, 2, 2, 3, 3. Indexes are 0, 1, 2, 3, 4, 5, 6, 7, right? Finding the first position. So first is equals to minus 1. Okay. Now you will say your low is actually equals to 0. High is actually equals to 7. From this, your mid equals to 0 plus 7 by 2, which is equals to 3. Mid comes here, right? Mid comes here, which is equals to 2, which is equal to target value. So change your first to 2. High will become 3 minus 1, that is equals to low. Low is equals to 0. Mid will give rise to mid equals to 0 plus 2 by 2, which is equals to 1. That is, mid comes here. Again, now this value is actually less. So you will say low equals to mid plus 1. That is, low will change to 1. 2, sorry. High is already equals to 2. That means mid will be equals to 2 plus 2 by 2, which is equals to 2. Mid will be coming here, right? You will say again, then you will say low equals to 3, right? Because the target value is actually greater. So low equals to 3, high equals to 2. As soon as this condition arises, you will exit the loop because low is actually greater than high. That is not allowed, right? Now moving for the last part. Your first is at 2, right? Now you will say last equals to minus 1, low equals to 0, high equals to 7. First iteration is same, that is mid equals to 0 plus 7 by 2, which is equals to 3. Your mid will come here. Your mid comes at 3, you will say it is equal to target value, so change your value to 3. That you have up till now you have encountered last as 3. Now because you need to find last, you will change your low equals to mid plus 1, that is equals to 4. High will remain 7. Your mid will occur 7 plus 4 by 2, that is equals to 11 by 2, which will in integer division give me 5. That is, your mid comes here. Again it is equal to target value, so change it, right? It changed. Now because you need to find last, that means low will again change to 5 plus 1, that is 6. High is 7, that means 6 plus 7 by 2. Integer division will give rise to mid equals to 6. Now because mid equals to 6, 3 is actually greater than 2, so you will say high equals to mid minus 1. That is, high will now change to 5, low will equals to 6, and that is that means loop will end. At last, first is at 2 and last is at, sorry, first is at 3 and last is at 5. I need to write the indexes here. First is at 3, last is at 5. So 5 minus 3 plus 1 will actually give rise to 3, right? And that is your answer, 2, 2, 2. Now because of this binary search, the time complexity has actually gone down to 2 log n, because we are performing binary search 2 times, one for first, one for last. 2 log n, O of 2 log n, and space remains O of 1, which is equals to O of log n time complexity and O of constant space, right? Space complexity. This is the optimized version of this code. I hope you are comfortable with it and ready to move to the coding section. Let us start with the code. So here we are in the coding section. My first approach will be to say my first equals to minus 1, my last equals to -1. Int, right? Oh, sorry, yeah. Now int low equals to 0, high equals to arr dot size equals to 1. Size -1. While my low is less than equals to high, what will you do? You will say int mid equals to low plus high by 2. First thing done. Now if three conditions can arise, if the mid element is equals to target, what will you do? You will say your first equals to mid, and because you need to find the first, so that means high will change to mid -1. Else, if your value, that is ARR mid, is less than target, what will we do? Because we need to find a greater value, we need to shift our domain to the right part, that is low will change to mid +1. Else, that is it is actually greater than, that will I need to check the left position, that is it is equals to -1. Again, low equals to 0, high equals to ARR dot size -1. Now what will you do? Again, same loop. So while low is actually less than equals to high, come calculate your mid, which is equals to low plus high by 2. If your mid element, that is ARR mid, equals to target, what will you do? You will say last equals to mid, and because we need to find the larger part, that is the last part, your low will change for the right domain, right? Else if ARR mid is actually less than target, if ARR mid is actually less than target, that means you need to again check the right part, that is low equals to mid +1. Else high equals to mid -1, right? Now return high minus low +1. That's it, right? Let us try to compile and run it. Hope it will work fine and will not give any error. Oh, there is an error. Let me check, guys. I found the error. It is last minus first +1, right? So I mistakenly write high and low, last minus first +1. Let us try it now. I hope it will work fine now. Running fine for the sample test case. Let us check for the submission test cases as well. There is an error again. Let me check, guys. So what is actually happening for the code of 11222223, and we have to find 4. Our output is, oh, okay. So I've not handled the case. I will just write if either last equals to -1 or my first equals to equal to 1. You can write anyone. Return 0 in that case. I guess it should work now. Because in the case when the element is not present in the array, it is -1 minus -1 plus 1. That is not correct, right? Okay, so thank you for watching. It is a 14-day streak and you have submitted it correctly. So thank you for watching. Hope you liked it, and make sure to like and subscribe to the channel. Thank you. Have a nice day.